Today we're going to start lesson 1.4. That begins on page 32, so I'm going to give you just a second to open up your books and make sure that you're on the right page. So page 32, 1.4. Once you're there, let's just get where it says scatter plot. It says a scatter plot is helpful in understanding the form, direction, and strength of relationship between two variables. Correlation is the strength and direction of the linear relationship between the two variables. And it talks about a positive correlation where the points for the most part are trending upward. The negative correlation where we're trending downward. Basically, as one variable is increasing, the other one is decreasing. And then relatively no correlation, which means the points are all over the place. There's really no correlation at all. If there is a strong linear relationship between 2 points, a line of best fit or a line that best fits the data can be used to make the prediction. So just know that there are correlations. Tomorrow what we're actually going to do is do some of these on the calculator, and we'll talk a lot more about the R values. If you look on page 33, there in the middle where it says the correlation coefficient R, it says the correlation coefficient R is a measure of how well the data set is fit by a model. So basically, the straighter the points are, the more they line up, the stronger the correlation. And the correlation coefficient measures from -1 to 1. The closer R is to -1, the stronger the negative correlation. The closer the R value is to 1, the stronger the positive correlation. And the closer the R value is to 0, the more there's not a correlation at all. And like I said, tomorrow we'll learn how to find the R value on your calculator, but in tonight's homework it's going to ask you some questions to help you decide what the R value might be. So for example, the first three that are on your note sheet, those points line up pretty well. You know, there's a few above and below, but you can tell that there's a positive correlation. That's going to have a pretty strong R value, probably around 0.8, 0.9. And again, tonight you're not going to have to know exactly what it is, just giving you the idea of what the R value is. The second set of data obviously has a negative correlation. And again, the points aren't perfect, but they're probably pretty close. But since it's negative, it's probably going to have an R value around -0.9. And then the third one, no correlation at all. So there's really no R value in there. So this one was negative. This one was positive. And then the third one, no correlation. Okay. The example that's on your table here has points. It has your X and it has your Y. What I want you to do is make a scatter plot, and you're just going to plot these 2 points. And it's done this for you, 116, 214, 311, and so on, and it's plotted all those points. So that's step 1. Make a scatter plot and plot your points. Step 2 says use a straight edge to draw a line. There'll be some points above and some points below. There's a little bit of guessing game here. Everybody's line might be a little bit different, but basically what you want to do is you want to draw a line that goes through a majority of the data with about the same number of points above and below. Okay, step 3, choose 2 points on the line to find an equation. You can choose any 2 points, and then again, that's another point where everybody in the class might have something different. I usually try and pick points that go right through a corner, like 116 and 72. It does not have to be points that you plotted, but it can be. So I picked 116 and 72. You're then going to use those points to find the slope. That's what we've been doing in DMR. So you're going to do the change in the y's over the change in the x's. So it's going to be 2 minus 16 over 7 minus 1, which is -14 over 6. If you reduce that, you get -7/3. I prefer to leave it as a fraction. I know some of you like decimals. I will take either, but just be careful. Fractions are easier to work with. I know you all don't think so. Decimals, I have to get my calculator out to figure. Fractions I can do without. Step 5 is use the point slope form to find the equation of the line. We have not used this equation this year, but it is something you've seen in Algebra 1 and possibly geometry. You can use your slope that you found and either point. I'm just going to use the first one, but you could use either point. And you substitute in and you say y minus y1, which is 16, equals the slope, which we just found out is negative 7/3, x minus x1. Distribute, and you get y minus 16 equals negative 7/3 x. A negative times a negative is a plus 7/3. And the only thing left to do is we normally like to put this in slope-intercept form, so we're going to add 16 to both sides. And you can do this in a couple of different ways. I'm going to go ahead and show you how to add and subtract the fractions. And I'm going to do this over on the side. 7/3 plus 16. I can make that thirds by multiplying top and bottom by 3. So that's 7/3 plus 48/3, which is 55/3. Or, if you want to do it on your calculator, I'm okay with that. 7/3 plus 16. Now it gives you that ugly decimal that I said I don't really like. You can write 18.3, or if you want, and this is something if you have a graphing calculator we haven't talked about yet, if you push the math button, which is the third button down in the first column, and notice the first thing that pops up is fraction. If you hit enter there and then enter again, it will change that to that 55/3 that I did by hand. So either way is acceptable. Again, I prefer the fractions, but decimals will be okay. Okay, let's do one more example together. It says use the scatter plot of data to solve. The correlation obviously as one rises, the other rises. So the correlation is positive. It's not asking you for an R value yet. We're going to talk more about that tomorrow. But it's just asking you is it positive, negative, or no correlation. Find 2 points. And again, you can find any 2 points. I try and find nice ones that go through corners. 0, 2 is going to be an easy one to work with. And 4, 8 looks like an easy one to work with. If you pick different points, it's okay, and you're going to end up with a different but similar answer that's also correct. The most important thing that I do here is I look at all the work. First thing you do is find the slope. 8 minus 2 over 4 minus 0, which is 6/4. That reduces to 3/2. So pick any 2 points. Again, I try and pick ones that go through corners. Find the slope. Then we're going to use that point slope form again to write the equation of the line. I'm going to use that point and that slope. Y minus 2 equals 3/2 times x minus 0. Y minus 2 equals 3/2 x. X minus 0 is just x, so that's nice and easy. And that 0 did work out to my advantage because now when I add 2, I can just add 2 to the end of the equation, and there it is. I can't combine like terms because the 3/2 has an x and the 2 doesn't. Let's take a look. We'll talk more about that tomorrow. Your homework for tonight is page 36, 1, 2, 5, and 9 through 12 all.